Hi. So the last tool we need to introduce to properly analyze equilibrium in neoclassical model of trade is the production possibility frontier. Again, this is something that you discussed in your introduction to microeconomics class, as well as we used it already in our class when we discussed the Ricardian model. Okay, so how does the production possibility frontier is going to look like in the neoclassical model of trade? Well, first we need to notice that actually the derivation of it is not as obvious as in the case of Ricardian trade model. So we're not gonna do it, which probably makes you very happy, taking into consideration how many proofs and derivation we've already did. Okay, so in our economy, the production possibility frontier is going to look like this. Here we have manufacturers, on this axis we have food, and production possibility frontier is gonna look like this. Okay, so let's remind ourselves maybe at the beginning, what does it mean? Look, production possibility frontier, it gives you the maximum amount of one good, for example manufacturers, that we can, that the producers can actually produce given some level of food production. But of course it works in the opposite direction as well. Okay, now, so what are all those combinations that we see over here represent? Look, those are effective combinations. First, it means if we are on the production possibility frontier, it means that all factors of production are used effectively. So, in our economy, it means there is no unemployment, every worker is working full-time, and all the capital is used. Okay, of course, look, as before, here we have all the combinations of food, of production of food and manufacturers that are beyond the reach of this economy because we do not have enough factors of production. On the other hand, if we are below, it means that we either not use all the capital or all the labor. So here we have all the efficient combinations, and those are the combinations that we are that are important to us because, as I remind you over and over again, this is a long-run model. Okay, now let's talk about a little bit about the curvature of the function. Because look, when we had one factor of production and constant returns to scale, we said that this function was a straight line. Here we see that it's the one we are dealing with is characterized by curvature. And look, this is not an accident, and we can actually relate again the curvature of the production possibility frontier, just like we did with the contract curve, to the technical parameters of production, so capital intensity in food and manufacturing industry. Okay, so let's start again. And here we will have food, here we will have manufacturers. So, look, what do we have over here? Let's just say that capital intensity parameter in manufacturers is equal to capital intensity parameter in food industry. With constant returns to scale again, this will give us a straight straight line. Now, as I hope you can guess already, we can now trace back what is happening. What if capital intensity parameter for manufacturing is increasing? For example, let's just say that now we have alpha M1. Okay, and as before, we will observe now that production possibility frontier is exhibiting more pronounced curvature. Then, if we would have again even bigger capital intensity parameter in manufacturing, we would have even more pronounced curvature. They of course start all in the same 2 points, but the curvature of the line is becoming more and more pronounced as one of the parameters is getting bigger and bigger and bigger. And of course, remember, this is not the case that we are discussing. We assumed at the very beginning that production of manufacturers is more capital intensive than production of food. Okay, so next question that is of extreme importance to us is, of course, about the slope of production possibility frontier. Well, we call it marginal rate of transformation, or MRT for short, and it is equal to the absolute value of the derivative df dm. But of course, what is important to us is what it represents. And marginal rate of transformation is a measure of the ease with which the producers can technically substitute the production of one good for another at the margin. Okay, and I hope at this moment you can clearly see a very big similarity between marginal rate of transformation and marginal rate of substitution in the customer's choice problem, right? Now look, if we would, of course, if we would just change production for consumption, basically we are getting the same definition. We calculate it with the same formula, but the important thing here is that, of course, the shape of the curve is completely different, right? Because over here we see function that is concave, right? Like part of a cave, while indifference curve is convex. Okay, and actually, this is not the only similarity, because in case of marginal rate of transformation, it is also good to add a corollary. Okay, and now look, if factor markets are perfectly competitive, and MC denotes marginal cost of production, of course. Then the following relationship, holds. And then we've got that marginal rate of transformation is equal to marginal cost of food divided by marginal cost, manufacturing at the top and food at the bottom, right? Because we have food at the top and manufacturing at the bottom here. Okay, and again, we can bring here a lot of similarities with marginal rate of substitution. Look, if factor markets are perfectly competitive, what does it mean? It means that the producers are taking prices of factors of production, so wage and rent, as a given, right? So in this circumstance, we've got again a similarity with the customer's choice model, where customers are taking prices of the goods considered, so food and manufacturing, as a given. Okay, now there's going to be one more important detail that we should consider over here. Now look, how are we going to choose which of the points at a production possibility frontier that the producers should choose? Well, look, producers are maximizing profits, right? So, what we need to have over here is a situation where marginal rate of transformation needs to be equal to the ratio of two prices. Only at this particular point, we'll have a situation in which producers are maximizing profits. So, knowing the prices, again, we will be able to track what is the level of production of food and manufacturers. Okay, but look, this is not everything that we can take from the production possibility frontier. Look, we can also connect it with Rybczyński proposition. Okay, give me a second. So, let's consider the production functions that we were discussing before. Like, we had manufacturers are produced according to Cole-Douglas production function, k alpha m times L to the power 1 minus alpha m. On the other hand, food is also produced with a Cobb-Douglas production function with k alpha m, alpha f, L 1 minus alpha f. And we also notice that alpha m is bigger than alpha f. That was our main assumption. We are assuming that production of manufacturers is more capital intensive than production of food, which is something I also repeat in every video, probably more than once. Okay, so now let's calculate differential of this function. We're going to do everything for manufacturers, but as you'll see, the result for food will come out as a byproduct. All we have to do is to just substitute. Okay, so look, if I'm going to calculate the differential here of manufacturers, then I'm going to get that this is derivative of manufacturers with respect to capital times change in the level of capital. So this is the first source of change in manufacturers, and the second, of course, comes from the impact of labor on manufacturers times change in the level of labor. Okay, so what we can do now is to calculate those derivatives quite easily, because we get that this is alpha m times k to the power alpha m minus 1, because we first differentiate with respect to capital, times L to the power 1 minus alpha m times dk. Then plus, we calculate the second derivative, so we get, now by second I of course means now the derivative with respect to labor, and this is k alpha m times L to the power negative alpha m, right? Because I dropped 1 from here, times dl. Okay, and what I'm going to do now is I'm going to divide both sides by m. So I'm getting here dm divided by m. Okay, and so I'm dividing by m each of these two components, and m, of course, is equal to that production function. So I'm getting that this is alpha m times k to the power alpha m minus 1, L 1 minus alpha m, divided by k to the power alpha m, L to the power 1 minus alpha m dk, plus 1 minus alpha m. This, of course, stays the same, k to the power alpha m times L to the power negative alpha m dl at the very end. And I'm dividing by Cobb-Douglas production function again. Okay, so now we clearly see that some things will cancel each other out, like those two and those two. But we can also notice that here we will have k to alpha m, those will cancel. The only thing left, we've got here k to the power negative 1, so k will go to the denominator. And here, alpha m minus L to the power minus alpha m will cancel over here. And again, we will have just L in the denominator. So now, putting this whole thing together, what are we gonna get? Look, we're gonna get that we've got dm over m is equal to alpha m times dk over k plus 1 minus alpha m times dl over l. So what do we have here? Relative change in level of manufacturers is equal to alpha m times relative change in capital plus 1 minus alpha m times relative change in labor. Okay, and look, by the same token, if we went through all these steps, we would get that relative change in the production of food is equal to alpha f times change in relative change in K plus 1 minus alpha f times relative change in L. Okay, so look, what is this result telling us? Let's imagine that the only thing that is changing is capital, while labor stays at the same level. And look what will happen in this economy. If the amount of capital is changing, of course those two are exactly the same, right? So what we get from this is that because alpha m is bigger than alpha f, then when level of capital is increasing by the same amount in our economy, then level of manufacturers must be increasing by more than level of food. And look, the best way to see it, if we would add here max. Look, because now you see that if the amount of capital in the economy is increasing, then, of course, maximum amount of manufacturers we can produce will be bigger than the maximum amount of food. And look, it also works in opposite direction. If alpha m is bigger than alpha f, then 1 minus alpha f is bigger than 1 minus alpha m. So now, if only the amount of labor is changing, we would see that if the amount of labor in the economy increases, then it will favor food, which means that maximum amount of food we can produce will increase by more than maximum amount of manufacturers. And look, this is something we can use with the production possibility frontier. Okay, please give me a second to erase the blackboard. So, well, let's just say that we are drawing production possibility frontier. Here we have food, and here we have manufacturers. Okay, and let's just say that at the very beginning, production possibility frontier looks like that. Okay, so now let's just say that we know the prices of manufacturers and food. Again, this should bring us the situation of Rybczyński proposition. In Rybczyński proposition, we are treating prices of manufacturers and food as given, right? So let's do this. So if we know them, we can find the point at the production possibility frontier. Let's call this one PF1. And okay, let's just say that this is going to be this point. So we've got here we've got the line, and this line is showing us the ratio of price of manufacturing to price of food. Okay, now let's imagine a case like this. When we had capital, let's assume that level of labor in the economy is constant. But let's just say that at the beginning we had some level of capital K1, and for this level of capital we had production possibility frontier 1. Now let's see what is going to happen if level of labor, of capital in the economy is going to go up. So we will have some new production possibility frontier 2. And look, according to what we specified over here, we should expect that because production of manufacturers is capital intensive, while production of food is labor intensive, then we would be able to produce a little bit more of food, but we should be able to produce way more of manufacturers. Actually, you know what I'm gonna do here is I'm gonna make this line even longer. Okay, now, what would I do? What should we do next? Well, again, we should find a point at which level of production in this economy will be chosen. For that, again, I need to use price of manufacturing to price of food ratio. So I should take this line, I should go up here, go up here, go up here, go up here, until I would arrive at a point where it is tangent to a production possibility frontier number 2, right? Of course, I'm not a robot, so probably those two will not be perfectly parallel, but I must say that I've done a job that is good enough. And again, we see that this is the same ratio of prices. So those two lines are perfectly parallel. Okay, maybe let me just to make the result more pronounced. Let me just put it over here. Okay, and then let's just say that level of capital in the economy is going up again to some level K3. And with this level of capital K3, there will be associated another production possibility frontier, PPF3. So what should happen over here? Look, again, we expect that now we can produce more food, but definitely we can produce even more of capital. Okay, I don't like the curvature, so I'm going to fix it. Okay. Okay, not that it's perfect, but let's just say it's good enough. Okay. Okay, so we go. Okay, now it looks nice. So, what should we do next? Well, of course, we should use our price ratio to find new points at which the producer will choose to produce. Right? So, what we do now is that I'm going to take this line. Again, I'm going to be moving it upwards, until we arrive at a point where this line is tangent to the production possibility frontier 3. But of course, remember, those three lines are parallel, so we got that this is the same price of manufacturers to price of food ratio. Okay, now, what can we see over here? First, let's think what Rybczyński proposition stated. in the nutshell, Rybczyński proposition said that in neoclassical framework, if level of one factor of production increases, let's talk about capital. So if level of capital increases, but we know the price ratio, so prices are given, then what we should expect is that the level of production of manufacturers is going to go up, and at the same time level of production of food should go down. Is this exactly what we see over here? Look, this is the initial level of production of food. This is the level of production of food after we had more capital, and this is the level of production of food after we had our third level of capital. So look, we can write here as F1, F2, and F3. Right? We clearly see that the level of production of food is now getting lower and lower and lower. And this is actually something I don't even need to show you. We clearly see that the level of production of manufacturers has been increasing by a lot. I don't even need to add a special line to prove my point. But if I did, it would be even more pronounced, right? So clearly we see that within neoclassical model of trade, just by using production possibility frontier, I can demonstrate Rybczyński proposition. But actually, it turns out that we can get even more. Look, I could create infinite number of production possibility frontiers like that, each associated with a bigger and bigger and bigger and bigger level of capital. Now, the interesting thing is that assuming the prices are constant, we would be getting a lower and lower level of food production and bigger and bigger and bigger level of manufacturers' production. If I would connect all those points with one line, it turns out that this line would be straight. Okay, I don't know how well you see it, but this line is downward sloping, right? It is going lower. It's really hard to draw a straight line when I don't have a ruler, but you see, this line is negatively sloped. But it turns out that in neoclassical framework, this line is always straight line. And what you see over here is called a Rybczyński line. And to be precise, in this case, is called Rybczyński capital line. Why is it called Rybczyński capital line? Well, because we quite easily could do very similar experiments for labor. Look, if I would, if now we would change the setup, and instead of having bigger and bigger level of capital in the economy, we would have bigger and bigger level of labor in the economy, the case would look like this. Okay, so look, again we are starting with some small production possibility frontier, and now level of labor is getting bigger and bigger. Right? Each of these levels of labor, assuming, of course, now we are assuming that capital is constant, is associated with different production possibility frontier. But now, because production of food is labor intensive, we should expect that increases in labor will favor the production of food. Okay, you see that the production of manufacturers at most increased by a little, production of food by a lot. And then we would have the third line. And now, what would we see over here? Look, the new Rybczyński line, assuming that, let's just say we are starting from this point, would look like this. We would observe that in this economy we are producing more and more food, which we again now can clearly see, but also that we are producing less and less manufacturers. So this one is going to be called Rybczyński. I'm sorry, Rybczyński. Rybczyński labor line. Okay, and this is it about production possibility frontier. In the next video, we are going to discuss the structure of neoclassical model of trade. So, see you in the next video.